let's talk a little bit about the reasoning for why a factor's exponent can cause it to cross over or double back when we're graphing polynomials. So our general, well, let's start off with the polynomial. So y equals, how about x minus 1 to the third and x minus 3 to the fourth. So our general rule is that odd exponent cross over, even exponent double back. So if we plot this, we know that at the 0 of 1, it should be crossing, and at the 0 of 3, it should be doubling back. Our leading coefficient is positive here, so it should be going up this way. Okay, so at 3, it's doubling back. So if we go down here, it's doubling back this way. And then at 1, it's crossing, so it has to be something like that. But why does it work that way? Why does an odd exponent cause it to cross? Why does an even exponent cause it to double back? To do this, let's plug in points and see what happens. So if we plug in 0 for x, then we get negative 1 cubed times negative 3 to the fourth. And negative 1 cubed is a negative, and negative 3 to the fourth is a positive. So negative times a positive, that's a negative. So we're going to be down here in the negative side. Let's plug in something to the right of 1. Let's plug in 2. When x equals 2, we have 1 cubed, then negative 1 to the fourth. Now 1 cubed, that's positive, and negative 1 to the fourth is also positive, so we're at positive. So we're going through here. And then, how about at x equals 4, we've got 3 cubed times 1 to the fourth, which is a positive, and a positive, so that comes out positive. So something like, wow, I missed that one. Something like that. That's still a bad curve, sorry. There we go. Alright, that's a little bit better. So look at what happened here. When we flipped over when we passed the 1 here, when we went from x is 0 to x is 2, this term went from negative 1 to positive 1. And because it's cubed, negative 1 cubed is a negative, 1 cubed is a positive. So flipping the sign of the result here, when we cube that keeps the flip of the sign. So it changes from negative to positive. So it goes right through, changes from negative to positive. But when we did the same thing at the other factor, this interior went from negative 1 to 1 here, but it stayed positive either way because this is a fourth power. Negative 1 to the fourth is positive, 1 to the fourth is positive. So it keeps the same sign. Even if the inside changes sign, if you've got an even power, that's going to stay positive. So we end up, instead of crossing over, which we would do if this turned out negative, we stay positive because it kept the same positive sign. So general takeaway is that when you've got an odd power, then when the inside flips sign, then that sign flip is propagated to the function itself. But when the inside flips sign and there's an even exponent, the even exponent kind of cancels out that sign flip, because it doesn't really matter whether the inside is positive or negative. Anytime you raise to an even exponent, you're going to get a positive result. So that's why the exponents, whether they're odd or even, that's why it either crosses or doubles back in the graph.